Okay, the next third one, magnetic field due to solenoid. Magnetic field due to solenoid is called as means the direction. Let us discuss the direction of magnetic field formed by a solenoid. Magnetic field is formed by a solenoid. So first of all, let us know what is solenoid. The solenoid is a long coil containing a large number of closed turns of insulated copper wire. Insulated copper wire. So, for example, if I turn this wire around the piece of chalk, or if I turn this wire, so around this object ఇలా అనుకుంటే right, so this is called as a solenoid. So it becomes like this. This is, so if you have many turns like this, then this wire is called as a solenoid. So if the current is passed through a long coil, that long coil is called as a solenoid. So when current is passed, when current is carrying by a solenoid, in which direction the magnetic field is formed. Let us know the direction. So a solenoid is connected with a current. So in which direction the magnetic field is formed? In which direction the magnetic field is formed? Let us understand. The magnetic field produced by current carrying solenoid is like a bar magnet, acts as a bar magnet. So this solenoid acts as a bar magnet. We know how the magnetic field is formed around the bar magnet. So magnetic field is formed around the bar magnet. So emerges from the north pole and entered into the south pole. Emerges from the north pole and emerges in the north pole and enter into the south pole. So as we know already, so this is the magnetic field formed by a bar magnet. Right. So similarly, solenoid, a long coil is also forms a magnetic field like a bar magnet. So the magnetic field formed around by the solenoid. So it forms this converted as north pole and south pole. The magnetic field is formed like this. The magnetic field is formed like this. So this is the magnetic field formed by solenoid. So the direction of direction of magnetic field. Direction of magnetic field resembles the magnetic field of solenoid. Magnetic field of solenoid. So same. So how this solenoid, solenoid, then the direction matters. Let us take one to another. So north south direction. North south direction like this. So resembles the magnetic field of magnetic field of bar magnet. Magnetic field of bar magnet. So the magnetic field line inside the solenoid are in the form of parallel straight lines. So like this. So bar magnet magnetic field lines are parallel inside the solenoid, outside. So like a bar magnet. This indicates that the strength of magnetic field is the same all at the point inside the solenoid. If the strength of magnetic field is just the same magnetic field is region, it's said to be uniform magnetic field. So uniform magnetic field is formed. Uniform magnetic field is formed because of the strength of the magnetic field inside the solenoid. Is same. The strength of magnetic field inside the solenoid is same. So it means the solenoid produces or creates a uniform magnetic field. Thus, the magnetic field is uniform inside a current carrying solenoid, has been represented by drawing parallel straight lines. This parallel straight line denotes the uniform magnetic field which is created by a solenoid. So one end of the current carrying solenoid acts like a north pole, then the other one acts like a south pole. So in case the current carrying solenoid is suspended freely, it will come to rest pointing in the north and south direction. So when we suspend a current carrying solenoid, it always represents the north and south pole because it acts as a bar magnet. Bar magnets has two poles, north pole and south pole. One end of the solenoid acts as a north pole, another one acts as a south pole. The magnetic field lines are formed like this. Then parallel lines inside the solenoid. So the current in each turn of current carrying solenoid flows in the same direction, due to which the magnetic field produced by each turn, the solenoid adds up, giving a strong magnetic field inside the solenoid. So the number of turns increases, the strength of the magnetic field also increases because of each turn produces magnetic field. So the number of turns in the solenoid increases, magnetic field also add up. That's why the magnetic field strength increases. So the strength of magnetic field produced by current carrying solenoid depends on the magnetic field depends on the number of turns in the solenoid. The number of turns. The number of turns in the solenoid. The number of turns in the solenoid. Then second one, the strength of current in the solenoid. The strength of current in the solenoid. And the final one, the nature of core material. The nature of core material. The nature of core material. What is this core material? Core material used in making solenoid. Which substance or material used for making solenoid? So the strong magnetic field produced inside a current carrying solenoid can be used to magnetize a piece of magnetic material like soft iron. So inside, to strengthen the magnetic field inside the solenoid, we have to use, when we place a soft iron inside the solenoid, thus the magnet is formed. The form is called as electromagnet. So a solenoid used for making electromagnet. To get the more strength of magnetic field, soft iron is used as a core material. For getting more strength of magnetic field. So that's why solenoids are used in making electromagnets. So this is about magnetic field due to electric current. So in case of straight wire, it is concentric circles. So if this is the direction of current, magnetic field formed like this. In case of circular loop or coil, it is formed perpendicular to the plane of circular coil. So in the previous topic it is said, so perpendicular to the plane of circular coil. So if it is the plane of circular coil, then the field is formed like this. Then in case of solenoid, so magnetic field is like a magnetic field of bar magnet. So bar magnetic field around the solenoid form by magnetic field around. So one end of the solenoid is acts as a north pole, then the other end is acts as a south pole. So this is about magnetic fields due to electric current. So this is about our session. Then next session we'll discuss about electromagnets and permanent magnets and force on current carrying conductor placed in a magnetic field. So thank you so much for your encouragement. So keep on watching my videos. Still, if you did not subscribe my channel, please subscribe, share the channel with your friends or relatives who are studying class 10 in various schools. Ask them once watch my video. If they like, ask them subscribe and share this channel with their friends who are studying in various schools. And once again I am requesting you, please watch my videos accordingly the topics which are going in your school. మీ స్కూల్లో జరిగేటువంటి టాపిక్ని బట్టి వీడియో చూస్తూ ఉండండి. ప్రీవియస్ చాప్టర్స్ అయినా సరే, ఇప్పుడు కంటిన్యూగా అవుతున్నటువంటి చాప్టర్లు అయినా సరే, దాని ప్రకారంగా మీరు వీడియో చూస్తే మీకు కాన్సెప్ట్స్ బాగా అర్థమవుతాయి. సో ఎనీవే, థ్యాంక్ యూ సో మచ్. Signing off. Bye bye.